going on, everybody? Mr. Barry here, trying to help out with doing some more examples. Hopefully give it a chance to check these out. What we're doing here is we're solving some quadratic equations. This one in particular is on the back side of your notes. 2x squared plus 7 is equal to 5 minus 5x. And we know we have a quadratic. Biggest exponent here is the number 2. And we're focused now on the fact that the equation is not equal to 0. So we do want to get things on the side of the quadratic term. It means taking the 5 and subtracting it over to the left, adding this 5x inverse operation over there as well. So I'm going to do that. Pretty much the whole right side is coming over to the left side. I'll subtract 5. I did that first just because it's there first and have my constant. 7 minus 5 would be plus 2. Still have that negative 5x over there. I'm going to go ahead and add that to both sides. No like terms on the left side now. The 2x squared, the 5x, the 2, all different types of terms. There's my quadratic. There's my linear term. And there's my constant. But finally, negative 5x plus 5x, we get the right side of the equation equal to 0. So I'm at this spot now where I can see this quadratic trinomial. We got to go ahead and take a look, and figure out if there is a GCF. So 3 terms. Take a look at the numbers, the coefficients. 2, 5, and 2. There's no number other than the number 1 that is divisible into that. So coefficient-wise, no, nothing. GCF, and then we have an x here and an x here, but no x for our constant, so no GCF at all in this problem. We're going to go ahead now and try this factor by grouping situation. So take a look. A, B, and C is where we're starting off with this, based off of a general form of a quadratic in standard form. A value is 2. 5 is our linear term, so that's our B value, and 2 is the constant. So A value is 2, B value is 5, C value is 2 as well. AC, in this case 2 times 2, would be 4, and B is the number 5. So specifically for this problem, in this process where we're starting to get rolling with the factor by grouping method, I want to try to figure out 2 numbers that multiply to AC and add up to B. So 2 numbers that multiply to 4 and add to 5. Not many options for numbers that multiply to 4. 2 times 2 and 4 times 1. That's it. And hopefully at this point you're thinking to yourself, yeah, 4 and 1. 4 times 1 would be 4. 4 plus 1 would be 5. So getting the ball rolling in this factor by grouping scenario, all I'm doing is replacing this middle term here, 5x, the linear term, with these numbers. We're going to throw an x behind it, with the process changing from a trinomial to a polynomial with 4 terms, which will help me do the factor by grouping. I guess I'll try to put this right here, or a little bit closer to this. So there's the 4x, there's the 1x, and on the back end I got a 2 as well. So again, nothing's changed in terms of mathematical basis here. This 5x and that 4x plus 1x, same exact values, just a different appearance. And now I can be able to try out these binomials that I have here and find GCFs if possible. First binomial, 2x squared plus 4x. GCF there would be a 2x. Removing it from these 2 terms and dividing it out would leave me with an x plus 2. We understand that part of this process of factor by grouping is that one of our groups will be made up of a common binomial, so we anticipate seeing that x plus 2 again. Kind of sort of already have it over there. There is no GCF for 1x and 2, so I'm just going to have a placeholder there for the number 1, which would leave me with x plus 2 in the parenthesis. Again, no GCF for 1x plus 2. We do need a placeholder of 1 here, and we do get the common binomial that we were looking for in x plus 2 in the parentheses. So one of our groups is the common binomial. There's x plus 2. The other group is made up of a combination of the GCFs, in this case 2x and 1. We now have this taken a look at intercept form. It went from standard form all the way to intercept form. We're happy with that because that's going to make life easier for us in terms of finding solutions to this equation if it was a graph x-intercepts. Apply that zero product property to our factors, x plus 2. Set that equal to 0. And we get a solution, x is equal to negative 2. Also want to do it to the other factor, 2x plus 1. We'll set that equal to 0. A little bit more work involved with this one. But regardless, we would get an x solution here. X is equal to negative 0.5. Of course, if you had it left off as x is equal to negative 1/2, that would be perfectly fine. So two solutions for us in this equation, the standard form equation that was started off, even with us having to get the thing equal to 0, even to start the process. Here it's in standard form. That 0 taking the place of a y from last unit lets us know we would be figuring out some x-intercepts here. But we take this standard form, we transfer it all the way to intercept form, and then we were able to solve for our two solutions in this problem.